Hey everyone, welcome to the new video. It is about sim and dim instruction. This is a super easy video. I hope you enjoyed. But before watching this video, this is my heartiest request to you that please watch the interrupt structure, the previous video. If you don't understand that video, the sim and dim instruction will it will just wasting time to watch this video. But before you start watching this video, please do watch that. Okay. So first, sim and dim. What is it? Sim is set, interrupt, mask. Sim instruction is a multiple instruction. Multiple instruction. When in program you write sim, you actually performed many operations one at a time. What? So sim, these are the pins that get affected when we write sim instruction. What are these pins? M5.5, 6.5, 7.5, MSC, R7.5, don't care, SDE, SOD. Now these four boxes are, I think, familiar to you if you have watched the previous video already. This is MSC. This is R7.5, which is reset 7.5. I've already discussed this in detail, but again I will discuss it. And these two pins. So let me start saying what they are used to do. So where do I start from? Okay, R7.5. R7.5 is for resetting 7.5. Suppose I'm doing something on my phone and I've locked my keypad. It's something sometime we'll just do that, and then press whatever you want to do. So now whatever you have pressed on your keypad, this will not come on your monitor, on your screen, because you have already locked it. Same goes, suppose we are doing any program and I have disabled all interrupts, so doesn't matter whatever interrupts come or not, I don't care. Like in that time what interrupts come, I just don't care. So they will come lost, whatever happens, but in meanwhile those interrupts will not be serviced. So obviously if you remember that D flip-flop and that OR gate, you have to clear that signal. Like if sometimes occur, then it goes to 0, but this will still produces 1, so you have to make it 0 so that you have to produce a clear signal. But in RST 7.5, as it is a edge triggered flip-flop, this is why the MUP needs to show that 0 to 1. So this is why reset function is used in RST 7.5. That input is needed for that. So for RST 7.5, please watch that previous video. Okay, the others. First, start from MSC. MSC is, in this MSC, either it can be 1 or 0. Obviously computers work on binary data. 1 is do masking and 0 is nothing. What does that mean? When we set 1 in this box, means you're allowed it to mask these 3 interrupts. Only these 3 interrupts can be masked by same instruction. I think you remember. So if I do this 1, means now I'm free to mask them. So suppose I do 0, 0, 0, means I'm allowed it to mask, but I don't want to mask any of these interrupts, so I've set 0, 0, 0. Then maybe I want to mask only 6.5, so set 1 and give the other 0. So these 3 bits, they can be whatever, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, according to your choice, according to the interrupt that you want to mask right now. You set the bits. So using MSC, you just give the permission to mask them. Okay, so if MSC is 1, means I'm allowed it to mask. If MSC is 0, means you are not you can't do anything, no masking is happening. Second is RST 7.5, it is already being discussed. This is don't care. This is SDE. SDE is what? Now here comes the point. See, so sim instruction, what is the task that it is doing? First, it is masking those 3 interrupts. Second, it is used for resetting 7.5, and the third task is Do you remember that SOD pin and SOD SID? I hope you have already watched the architecture video, and there was the serial in data and serial output data. So when we have first SDE, this is serial data enable, means if this bit is 1, then I'm eligible to send some data using this SOD. But if this pin is 0, means it is disabled. Like if you keep this 0 or 1, whatever you keep, this will not affect my processor. Okay, why this is important? Why is this important? Suppose you perform sim. Okay, and now you can't keep them void. Either you have to put 0 or 1. If you put it 1, it will send the data 1. But suppose I don't want anything from that, so I need to disable this pin at that point. So this is why SDE pin is important. This pin will give you the permission to either store 1 or 0, so that any like misprogramming not happen in this while doing some other programs. So an SOD is, if it is 1, then send 1 through your SOD pin, SOD serial output data, and if it is 0, then send 0. Okay, so how this gets performed? Suppose, let me take an example. These are your combination. How this is actually performed? Suppose I want to mask these two bits, so 1 1 and keep it as 7.0 as 0. Now MSC, obviously as I'm masking, I need to enable it. Now reset 7.5, it depends on you whether you want to reset or not. Suppose I don't want to reset, so it's 0 and it is don't care, and this is STE, so I just don't want to do anything in that. Then this data is 1 2 4 8, that is 0. This is 8 to 11 0, sorry, 10 is A, 11 is B, so this is 0 B. This combination can be represented in hexadecimal as 0 B, right? Now whatever operation you perform, it the main like who's the planner, that is the accumulator. So if you want to like perform these operations using same instruction, what you have to do? First MBI A, 0 B H, and then just do sim. So A will store 0 B, and when we write sim, this A will just contribute the bits according to this pattern. Okay, this is how sim instruction gets executed. Next is read in RIM. Read interrupt mask is, it is a passive instruction, means when we write RIM in our program, we will just, if you use a Zubin simulator, I think you've already seen this. When we write sim, this will just show the data that whatever you have performed already, okay, on your interrupts and all. So read interrupt mask is when a programmer wants to know that whatever task has already happened, whatever done in my programming, then RIM is used. What are the pins? M 5.5, 6.5, 7.5 IE, then there is I 5.5, 6.5, 7.5 and SID. First let's start from IE. IE is interrupt enabled. I think you already remember that in IE I've used that INTER flip-flop. Okay, so when we write, when there is 1, means interrupts are now enabled. If that pin goes 0, if the pin is 0, if it shows 0, then this means the interrupts are disabled, so not any operation can be performed. Then if any of these bits are 0 or 1, according to that you can understand whether that interrupt is masked or not. So using RIM instruction, you are not performing any operation, you just want to show you, like I want to see my data. Okay, so if there is if the processor shows you that this is 110, means 7.5 and 6.5, these two interrupts are masked and this is 0, right? So just focus on this word, masked. So when the processor shows that this is 1, this is 1, this is 0, means these interrupts are masked and this is not. This is just showing you the result. Okay, and this is a passive instruction, that this will not affect your MUP. So, see, okay, this is just showing you whatever task you have already done. Then you know already what is interrupt, pending interrupt. When suppose I'm doing my program and some interrupt occurs, but I was busy in my programming, so I told them that hold. When the MUP is now free, this pending interrupt will now get serviced, but for the time being it was as it was pending, so this is why this is called as interrupt pending. And when this is 0 means nothing. So what will happen, that if something is 0, 1 and 1, suppose this combination is there, means that my 7.5, that interrupt is now on pending state, there is nothing in them, and in 5.5 this interrupt is also on pending state. So these 3 bits are used for showing whether which interrupts is pending or not. And SID, obviously serial input data. If I use 1 means if it is 1 means that 1 is present on SID. If it is 0 means 0 is present on SID. Okay, so when I do sim means I'm performing some task on MUP, and when I do, so this is an active instruction, and when I do rim, this is a passive instruction, means this is just showing what I have already done. So using sim we affect the MUP, and using rim we don't affect the MUP. So suppose that you are just writing your data, write rim, and in your window, in your simulator, all those scenarios, all those boxes, you will just see all the data is being shown. Like if it is suppose 1 0 1 1 1, okay, if this pattern came, means that first it is 1 means my interrupts are enabled now. So, and these combination shows that this and this interrupt is masked and this is not. When this is 1 1 and 0 means they are on a pending state, and this is 0, this is not on pending state, and this is 1 means 1 is on my serial input data. In that pin it is occurred. So this was for sim and name instruction. This was a short video, and I think it's an easy one. Though if you have any queries, please ask me in the comment section. Thanks for watching. All the best.